I presented to Lisa last year in Baltimore. I'm glad to be able to present to you again. A lot of the material that is in my slide set has been presented in slightly different ways by the earlier presenters, which is actually a good thing. So you'll have some familiarity with those topics, and then I can drill down a little bit about some of the security aspects. So the topics that I'm going to talk about briefly deal with some of the network security issues, rights management, the crypto framework, and trusted extensions. Just if you don't know me, by the way, I'm the architect who did the design of trusted extensions. So let's starting off as just a quick overview of some of the network security features. This is actually a slide from Solaris 10, but of course it still applies to Solaris 11. Built into Solaris, now Oracle Solaris, is the IP filter capability to restrict specific ports and so on, and uses the standard IPF management interface. TCP wrappers to restrict access from specific domains. And secure by default, which is the feature by which an SMF profile is initialized to turn off, that is to disable all external network services except SSH. What's new in particular in the next slide is that this now applies to zones as well as to the global zone by default. So if we drill down a little bit, as I said, in the area of zones, some of the features you heard earlier apply as security features as well. For example, the exclusive IP stack features that were talked about earlier not only allow use of VNIX, but also allow services like DHCP to be configured automatically as DHCP clients, that is, in a zone. IPsec and IKE daemon can run in a non-global zone. IP filter can be configured in a non-global zone, and the secure by default SMF profile is also initialized by default, so that zones are a security boundary as far as all the other features, but now the network isolation and network management security features of zones have been enhanced. I'll talk about zones a little bit again later in this presentation when I talk about trusted extensions. The Kerberos has been improved in a variety of ways to make it easier to use. For example, a Kerberos client can now take advantage of a zero configuration option where the Kerberos identity is Kerberos KDC service is discovered through DNS. We also have a new PAM module for doing authentication based on PK init to Kerberos. And Solaris clients can be full Active Directory clients and the credential provided by an Active Directory server is fully recognized. We have a extended CIFS-based credential so that Microsoft user IDs and Solaris user IDs map one-to-one. And we have a new tool, a KDC manager, for managing a key distribution center on an Open Solaris or Oracle Solaris system. Process rights management is another feature coming from Solaris 10. As you probably know, in Solaris 10, the fine-grained privileges that originated from Trusted Solaris were integrated into Solaris 10, and this slide just shows an example of how several different privileges are used to restrict what individual processes can do. And this feature is basically the same in the Oracle Solaris 11 Express release, except that we have some additional, more fine-grained privileges. But we've also done some other stuff that I wanted to clarify. This morning, and actually in all the presentations, there were references to the command pfexec. Now, pfexec is an implementation from Solaris 10, which was used, which was called indirectly because you were supposed to, the intent was that users of Solaris 10 would use a profile shell namely like PFSH or PFCSH, PFKSH, and so on. And what those shells would do is look up for that user to see if the command that was being executed was defined in one of the user's rights profiles, and if so, it would invoke pfexec. Now, what happened in practice is people got used to just running pfexec directly. It was never expected by the designers, which was me, that pfexec would be used as the primary interface. And one of the differences you might have noticed when you looked at Open Solaris and compared to what we have now in Oracle Solaris 11 Express is the reference to sudo and kind of deprecating pfexec. Well, the message isn't quite that. It's not that we're deprecating pfexec in favor of sudo. In fact, we don't need pfexec anymore. We never really needed it in the first place, but we've really made it unnecessary by virtue of incorporating into the exec system call the behavior of what pfexec does, which is that if a user process invokes any of the various shells that begin with PF, and now all the shells begin with PF, the default shell in Solaris 11 is actually bash. Shell is linked to bash. But all the shells that we ship with Oracle Solaris 11 have a PF equivalent. And all that does is execute the system call to set a flag called priv pfexec in the credential. So we have what we call process flags in Solaris, and the new flag called pfexec is set when you execute one of these PF shells, including pfexec, and that's set in the credential. And then it invokes the specific shell that corresponds to that name. So if you were to say pf bash something, all it does is set the flag and invoke bash. But the flag is then inherited by all the children of that process. So the flag is persistent, which means you never need to invoke another profile shell again. Once you've invoked any of the profile shells, all of the child processes also go through the pfexec equivalent logic in the kernel. And the implementation is managed through a door call, what we call an up call in doors. In the exec system call, when the flag is set, calls a daemon, the pfexec daemon, which then attaches the appropriate process rights to the command that's being executed as a new process. And you don't therefore need to invoke it with pf anything, because it happens automatically. So that means you no longer need to modify shell scripts to make them into profile shell scripts or anything of that sort. If you give a user the PF equivalent of whatever normal shell that user would have, then all of the user's execution is subject to the RBAC policies. So you don't need to run sudo, and you don't need to run pfexec. And in the examples that you saw this morning, where people were using sudo and then the package command, you don't need to put sudo in front of the package command. You could just put package by itself if you've previously invoked any PF operations. So that is the intent, that we don't need to run sudo, we don't need to run pfexec, we just set the flag. Now the reason we don't do this automatically is there's a performance overhead, because that means we need to check for every execution that is, when this flag is set in the credential, all executions will be looked up through a door call to see whether or not there's a corresponding rights profile entry for that command. So you don't want to do this for everybody, but you do want to do it for administrators. So it would be normal for an administrative role to have a PF shell, and then all of the operations that are done by that administrator will be subject to going through the RBAC rights profile system. Another thing that is also a feature that comes out of this design is we have a new rights profile called forced privileges. And this isn't one you're necessarily supposed to modify. It doesn't get assigned to people. It's instead implicitly associated with all the executables that are set UID to root. So when the kernel executes and discovers any binary that has the setuid to root privilege, or attribute on the inode, the kernel will make the same door call to the daemon, which will look up the privileges for that setuid binary. So this allows us to run most setuid binaries with reduced privileges, since many of them don't in fact need all the privileges, like the privilege for almost anything that is specific. The package command, for example, if they're just calling a privileged system call, a network configuration, for example, then we can reduce the privileges. This is transparent to the applications and to the users. You don't need to modify the applications to do privilege bracketing. It happens at exec time. Okay, there are some changes in user rights management. And again, this is a feature that was introduced in actually Solaris 8. Solaris 8 was when we first added authorizations, and we've extended in roles. So this has been extended in Oracle Solaris 11. A couple of things that were mentioned earlier this morning. By default, root is now a role, which basically means that it's not a login account. It also means that somebody has to be able to assume the root role, so that we require that you create at least one other account when you install Solaris 11, because how else are we going to assume the root role? So the first account that gets created during the auto install process is the account that can assume the root role. Also, that account can use sudo. So both mechanisms are available. Now, it was earlier mentioned this morning, Dave Miner mentioned that we used to assign primary administrator, primary admin to the initial user that was created by the auto install process or by the live CD install. We don't do that anymore, but what Dave didn't mention is we do something instead. What we do instead is assign the software install rights profile to the first user. So that's why the first user can run commands like package and beadm and things of this sort without having to run sudo, because you already have those things from a profile shell. The second feature on the slide, which was just mentioned earlier when Dan was presenting, is that we now have extended RBAC into zone management, so that we have per user and per zone authorizations to determine which users can log in to do a Z-login, which users can boot a zone, and so on. And the reason cloning is included there is we want to make sure that you can't use as a source zone for a clone a zone that you're not supposed to know about. So you have to, for the specific cloning right, you have to have two authorizations. You have to have the manager authorization for the zone you're making and the clone authorization from the one you're starting with. Sandboxing is another feature that is a side effect of the new implementation with the pfexec daemon. We now have a new reserved rights profile called stop, and when this is assigned in the list of rights profiles in user adder to a user, it prevents further lookups. So this is a termination of the list of rights profiles and implicitly also the authorizations in them. So if a user is assigned some number of rights profiles followed by the word stop, then no subsequent lookups are done and the policy.com file is not consulted. So this makes it very simple to create specific accounts which are limited in very precise ways as to which commands they can execute. So you could create a kiosk account or something of that sort which could only execute 5 commands, and or is limited to only have very specific authorizations and privileges, and wouldn't inherit anything from policy.com or from other rights profiles. So this is a very useful feature. and that you don't have to change you don't have to affect anybody else. There's a question in the back. Okay, so a couple of things. The question is basically, what do you do when your network is down and root as a role? The question came up this morning as well. So the first part of that question, first part of the answer is, in single user mode, we don't go through PAM. And the root as a role check is in the PAM roles module. So during single user mode boot, PAM is bypassed. At least that PAM module is bypassed. So it doesn't apply. You can log in as root. The second part is you would need to have a local account, some local account as an emergency if you want to be able to get in. You can also disable this feature. This is only an out-of-the-box configuration. If it's really objectionable to you to make root a role, there's on the role mod command, there's a -K option to turn it back into a normal account. So if you really hate this, it's configurable. Okay. So the next thing to talk about briefly is the crypto framework. Again, this was a feature introduced in Solaris 10. The crypto framework is basically a standards-based implementation whereby we can plug in new crypto modules and new algorithms and new providers and so on. The architecture is essentially the same in Solaris 11, but we have some new modules in terms of acceleration and performance. So one of the things I wanted to tie into the earlier presentation on ZFS and the encryption feature that was added to ZFS, most of the encryption in Solaris, including in the Oracle stack of database and middleware, is taking advantage of the lower level crypto framework in Solaris. So when we talk about numbers like a 3 to 7% overhead for encryption in ZFS, those kind of numbers are dependent on what hardware you're running on. So we take advantage of the hardware encryption on both Spark and x86 processors, and that's why we're able to get that kind of performance. But if it's done strictly in software, if we don't have crypto hardware, then of course it's not going to be as fast. But that's transparent to the user. I'll talk about ZFS crypto again in a minute, but I wanted to also mention that in addition to ZFS crypto, we now have a LoFi crypto. That allows us to effectively have crypto devices that, like a USB stick, that can be managed as a full encryption when it's mounted and through LoFi ADM, and then stays encrypted when it's unmounted effectively. So that is a useful feature for removable media, and that also takes advantage of the crypto framework. Now back to ZFS. This is obviously a new feature interestingly, from a timing standpoint, it was the last significant feature that was added to the Oracle Solaris 11 Express. We had to squeeze that in right at the end. It was a feature that has been worked on for some time, and we're very pleased that it's available now. A couple of things that are interesting from a security standpoint about the implementation. The encryption option is a create time option. That means you can neither disable nor enable crypto on a ZFS data set once it's created. It's either encrypted at creation time or never encrypted. But it's transparent to all child data sets. So if someone, let's say an administrator, has created export home as a encrypted data set, then all per user home directories created under export home will also be encrypted data sets automatically. They have to be. You don't have a choice. But they will initially be in the passphrase or the key phrase for accessing and mounting those child data sets by default is the same as the parent. So you inherit the key from the parent. It's called a wrapping key. But an authorized user of that data set, that means someone who has been delegated the ZFS permission to modify the key, can then provide a new key, different from the parent. So the way this can be used is each user can have his own data set for his home directory and can provide a unique key for that user, which might be the user's actual password, so that no one else can, but the user can mount that home directory. Now, this presents both advantages and disadvantages. When I've discussed this with some of our government customers, I thought they would like the idea, but it presents significant problems for archiving and management, because you can't really you can't back up these data sets because they're encrypted if you don't know the key. And you also can't, from an auditing standpoint, if somebody is a criminal, it's tougher to catch them. So these are things that have to be considered from a management standpoint. Now, we're not, as Oracle rules here, we don't talk too much about future features, but we do have a project underway to automate this process through a PAM module, so that when users log in, if they have an encrypted home directory, when they authenticate through PAM, we can use that password as a decrypted key to mount the per user home directory. So this is an example of how this could be managed. Similarly, we have some enhancements in the tools for creating users, which will also be aware of ZFS, and creating user home directories as ZFS data sets that can be similarly encrypted and delegated to the users for both using the time slider snapshot mechanism, or which is where you can have automatic backups and promote backups of your home directory, as well as provide new keys for encrypting them. As far as key management, we have a new plugin to the crypto framework that's used by the Oracle key management system called PK611 KMS that will manage keys through that product. And we also have a number of enhancements through new providers in the crypto framework that accelerate some of the performance and provide new algorithms for AES. We have CCM and GCM modes that are taken advantage of through IPsec and ZFS Crypto. And we also have elliptic curve cryptography support modules for IKE and RSA and DSA negotiations. The new Spark T3 processors have built-in crypto performance, hardware acceleration for AES, CFB mode, which is used by the Oracle Database Advanced Security options. So this gets us better performance for cryptography through the database. And we also have a number of framework enhancements for a trusted platform module, which is, if you're not aware, on all of the Sun Oracle hardware now, these new processors are shipping with an onboard tamper-proof module for key store called a TPM. And there's a new library and API called TSS 1.2, which is a standards-based library for talking to the TPM. There's a TPM ADM CLI for managing and initializing the trusted platform module, and a new crypto module to plug into the crypto framework called PKCS11 TPM. Last thing I'm going to talk about is trusted extensions, which was introduced also in Solaris 10. This is basically a special mandatory access control framework based on Solaris zones that is used to provide label-based separation between processes running at different labels. So I'm not going to get into, if you're not familiar with trusted extensions, basically it's a successor to what was trusted Solaris. It's used primarily in military intelligence communities around the world to make sure that data that is supposed to be kept separate based on its security classifications is maintained that way. So this, again, was derived from all its predecessors going back over the last 20 years, but we've made some interesting extensions and new features for this new release. The first one is, we used to be based on CDE, the Common Desktop Environment, but CDE has been removed from this release. So now it's based on GNOME. We use the GNOME Login Manager, which is now label aware. All the other components that are relevant in GNOME, including the panel, the window manager, and this thing called the trusted stripe, are all enhanced to work properly in the latest version of GNOME, which I think it's either 2.30, I think, is the version. It's the latest version of GNOME, the same one that's in Linux. Another thing that we've done is to provide the option on a per zone basis to have unique credentials per user and per zone. We used to provide a common credential for all labels that a user was clear to operate at, but now that we have ZFS crypto, we want to provide the option to have a unique crypto key for every label that the user is operating at, so that they can have a uniquely encrypted data based on the user's identity and the user's clearance. So the individual home directories can be separately protected based on their unique ZFS crypto key. The other thing that's interesting, if you follow what's going on in the Linux community, SE Linux has added a type enforcement-based policy to the X server, and for our X server, or the Xorg server in Solaris 11, we use the same hooks that they use in SE Linux. That's called the X-axis control extension, so that we can use the same framework that's used in SE Linux, but in our case, the hooks are based on the trusted extensions, labeling, and the privilege policy from Solaris. Another thing that we've done is to add an interesting ZFS system attribute called an MLS label, which is generated automatically when a data set is mounted on a system that is running trusted extensions. So when you mount any file system, any data set on a trusted extension system, the kernel records a new system attribute called an MLS label, which corresponds to the label of the zone in which it was mounted. At that point, from that point on, it can't be mounted anyplace else. It can only be mounted into another zone with the matching label. So this prevents administrators from accidentally mounting data sets in a way that would violate the labeling policy, and also provides an assurance that meets certain evaluation and accreditation requirements so that these systems can be deployed. And finally, the labeling policy has been extended to IPsec, so that we now have a multi-level IKE daemon which negotiates security associations that include the MLS security label. The label is protected for both confidentiality and integrity, so that the label can't be either spied upon or modified in transit. And that means that the previous labeling mechanism, which was a modification of the IP4 header to include an explicit label, is now optional. It doesn't need to be sent in the clear anymore, and it provides the ability to run a multi-level system over a hostile network.